Hello, and welcome to Module 4 of our FAIR Data Training for Deep Ocean Early Career Researchers, DOERs, in the iDOOS project. So today we'll be talking about the R in FAIR Data Lifecycle, reusable data. And if you'd like to follow along with these slides, please follow the tiny URL here. Type that in. Let's go. Great, so welcome. If you are new to the iDOOS project, this is the Implementing a Deep Ocean Observing Strategy project funded by the U.S. National Science Foundation. And DOOS more broadly is an international network of ocean observing and mapping and exploring scientists endorsed as a UN Ocean Decade program. And I'm Stace Beaulieu. I'm here with you today. I'm sitting in Woods Hole, Massachusetts right now. And in our live session, we'll be joined by seafarers, including Karen and Leslie, as shown on the slide. And I'm looking forward to be joined by you, the doers from around the world. We'll start off the live session with our principles of collaboration and our code of conduct. And we'll talk about how we're going to use Zoom. Again, the live session, we prioritize time for interacting with each other and sharing. So that's why I'll be stepping more carefully through the slides here in the recording. This course is a series of 4 modules. This is the last one today. We've almost completed the research data lifecycle. We started learning about FAIR principles, stepped through the research data lifecycle, and we're going into the preserve and reuse steps today. I try to think of this training as putting 100 years of experience into an 8-hour online course. To recap, because you don't have to have attended any of the previous modules. Today, you can be fresh. We can recap quickly. We defined the findable, accessible, interoperable, and reusable data principles. We stepped through the life cycle. We did some homework. We did homework to learn by doing, the F and the A, and the describe step. And in each live session, we've had breakout rooms to discuss good enough data management practices, to discuss collaboration tools, data processing, vocabularies, and standards. We're coming out of Module 3, where we were doing the collect, process, and assure steps, and we also integrated the describe step at each of these steps of the life cycle. We also acknowledge that quality assurance starts even at the collection phase. And today we will get to the preserve step and reuse some data as well. What will we learn in Module 4? So we're going to conclude the steps in the research data lifecycle, and then we will initiate a new cycle by reusing data in the ocean sciences. And the learning goals are to be able to apply the reuse step to data of your own interest, to understand the concept of reusable, the R in FAIR data, and to remember concepts that are related to the preserve step. These quotes have followed us throughout the training. Why make research data fair? We focused on benefits to ourselves and to others in modules 1 and 2 respectively. In module 3, we focused on the enabling easier data integration within across disciplines. And today, as we get into preservation and reuse of data, we're going to show how FAIR data can support worldwide multi- and interdisciplinary research endeavors to address our global challenges. So what will we learn today? So we'll start with the first session. And yeah, we have two 1-hour sessions. They're going to be held 1 week apart, so enough time to do homework in between. Today we'll start with the preserve step, go into an anchor article by Wood Charlson et al. We'll do breakout rooms to learn by doing ERDAP. We'll learn what ERDAP is, and we'll get exposed to data citation to lead into the homework. To start off the preserve step, I really love this set of questions from, it was a workshop that, or a session at an Earth Science Information Partners meeting held by graduate students, and it was what I wished I learned in grad school. So these were the 3 questions that came out of this workshop session. Where are your data going to live for the long term? How might your data be used in the future? And are there any security or privacy issues with sharing your data? Starting with the where. Where I borrowed this slide from a previous set of training that we delivered at Woods Hole Oceanographic. And the where, we like to think about preserving or publishing the data for future discovery by others. But where to start? Choosing where often starts with who is funding the research, because there may be requirements from your funding agency as to which data repository you should choose. And then with regard to the privacy or sharing limitations, are there any limitations to who can access the material? Then choosing where, we like to think about your end users. What type of data? So do you want to share your data within your discipline? This can really vary across disciplines. In the ocean sciences, you might choose a different repository if you're working with physical oceanographic data as compared to biological oceanographic data. And in terms of type of data, you may have big volume of data as well, and different repositories can have different limitations, size limits. They may have requirements with quality assurance, for example. So in the live session, I'm going to ask the doers in the room, have you submitted data to a repository? And I clarify this because we've talked about an online tool, GitHub, in the past, and GitHub has this same word, repository. We are distinguishing here research data repositories or archives. And types of repositories, we'll just go over 3 different types, starting with the domain repository as kind of a preference as to where you might want to direct. If you're really creating a product that you want to use within a discipline or within a domain, you might want to aim for a domain repository, which has a lot more, maybe has more services added on to those data. I love this diagram. It was created by Kirsten Leonard, so thank you for sharing. There is, in the slide notes, you'll find a link to the published paper that has a more polished version of this diagram. But the diagram climbs steps, right? So it climbs steps from generic repositories, which may be something like Zenodo, you may have heard of that, Figshare, for example. And so generic repositories can provide a persistent identifier, which we'll get into soon, for your data to have them findable, and of course make the data as accessible as allowed. But domain repositories add that reusable and interoperable component, which adds value. In between, we have an institutional repository. So this may be a library repository at your institution, for example, that can add some services over what you get from a generic, but would not be tied to any particular domain. So in general, in terms of recommendations, if you're thinking about reuse of the data, often you might want to start within your domain and then move on to with your institution, and then lastly choose the generic repository. So for fun, during the live session, we're going to search the Registry of Research Repositories just to get a feel for what repositories are out there. And one of our early career researchers in this project, Brennan Phillips, asked for the 30,000-foot view of what repositories are out there. So I'm going to actually just, for kicks here, I'm not going to open this registry of research repositories. And just so show you, first of all, there's a lot of repositories here. This covers any domain. So let's get into subjects that we care about. I'm going into subjects. I'm going to scroll down to, I'm passing life sciences. I'm going to go into the earth sciences or natural sciences. I'm going to find oceanography. I might have to do a little search. Oh, I found it. That's good. Oceanography. And I found 185 results. Just so happens the first one I hit on is the institutional repository where I'm sitting today. But as we scroll down, we can find, in this case, there's many specialized repositories going on here in the ocean sciences. There's a lot to select from, coming from different countries. I've seen the UK, I've seen the US, here's Norway. So we have a lot of choices here. And in the live session, I also would like to search by country, and I'll use India as the example to follow up on one of our doers who gave a plenary talk at the May DOERs meeting. There are a couple examples of repositories that are involving India, tagged by country. And I just wanted to point out, there's a paper that talks about this, but access to a repository it may not be independent of where you are geographically located. So we need to think about that in terms of access. Not everybody in the world has the same access. Just do our best with the selection of a repository that provides that open access. So we had this slide in our training at WHOI with regard to habits for sharing your data with repositories. And the number one tip, Brennan, I can talk with you here just in terms of the overview. The number one tip is to start early. Why? Because it does take some time, it does take some work to preserve your data for discovery. Communicating with collaborators, I personally have found to be important as well to do early. Many of the data that I work with are in projects with many other people, so we want to get everyone involved, really, in preparation of metadata, for example, that are shared along with the data into the repository. And this question here, what if you have big data? That is why I moved this sharing or communicating with repository data managers. It was kind of lower on the list earlier, but I moved it up because if you have big data, I do recommend contacting the repository early to talk about how to do it. How much of your data will you provide out through the repository? And there is a wonderful rubric. If you have model data, this link to an EarthCube Research Coordination Network has a rubric of kind of high-level things to think about when you want to decide of how much of your model data to share out. And I know that's just some of us in the room are going to be observational scientists and may want to be thinking about, high volume imagery, for example. But this is a great rubric for the modelers in the room. So as we think about sharing our data out through a repository, I chose this particular article as the anchoring article for this section of the lesson by Wood Charlson et al. It's a new paper, 10 Simple Rules for Getting and Giving Credit for Data. And I'm not starting with rule number 1. I'm going to start with rule number 4 here to tie into repositories because it's a way to get your persistent identifier. The way to get a PID, not only for your data, but also for yourself, right? So I'm going to highlight two persistent identifiers here. We'll highlight a DOI, or digital object identifier, and we'll highlight an ORCID ID here. So first question to the room, we're going to ask the doers in the room, have you had a DOI created for a data set? This is one service that can be provided to you by a repository, and an example being here. I'm actually going to use this DOI later in the lesson for a data citation, and I'll talk a little bit about how I found that DOI. The next question to the room, do you have an ORCID identifier? ORCID is a nonprofit organization that creates unique identifiers for researchers. It's not the only identifier, it just happens to be one that is well used today. And I have one. I was interested. I actually, in the slide notes, you'll see you can actually search. It was interesting. I could search on myself and I could see how many data DOIs were associated with my ORCID identifier. So we know that we've been talking about the preserve for, or publish for later discovery. So the preserve step connects you to someone else's reuse step. And in the live session, I'm going to click on this paper by Rug et al., Completing the Data Lifecycle. And we're going to look at figure 1. Unfortunately, it's not an open access paper, so I don't feel comfortable sharing that image here in the recording, but it is a wonderful image that kind of shows where our projects are in terms of our production of data and publishing of our own data, and then how that connects to the reuse steps by others. So to learn the reuse step, I love to just jump in, right? So we're going to jump in the live session. We're going to learn by doing. And I've been talking about research data repositories, and we heard that a repository is a way that can create a persistent identifier for your data set. Well, a repository or an archive, it can also provide other services that are valuable, right? I mentioned metadata earlier. We mentioned ontologies in Module 3. Today, we're going to talk about the software services. And many repositories in the ocean sciences provide this software called ERDAP and services around ERDAP. ERDAP is a data server. It was developed by the U.S. National Oceanic Atmospheric Association, NOAA. And ERDAP, there's a link here to the Coast Watch definition. So it used to be an acronym, but it outgrew that. So today we use ERDAP like a word. And we're gonna go into, when we do our breakout rooms, we're actually gonna explore some data from DOERs ERDAPs. And I was really kind of impressed that there's a lot of ERDAPs out there, first of all, in the online world. And many of our DOERs partners, if you were to go into the RE3 data and search for Ocean Networks Canada or Ocean Observatories Initiative, you'll hit on, first of all, you'll find them in the RE3 data, and you'll be able to access their ERDAP servers. The activity that we're going to do for the ERDAP server is actually going to have us interact with the A, I, and R in FAIR data. Why not the F? Well, we're going to give you the F. You're not going to find the ERDAP server. We're going to tell you where to look. And you'll be able to choose which one you want to look into. So why ERDAP? Why have so many repositories chosen this particular data server? Because it provides a consistent way. Yes, you can download, but you can also just directly access subsets of gridded or tabular data in various common file formats in the ocean sciences. And ERDAP is both a web application, so it's a web page that you can interact with. So you can use it to subset data, make graphs, read the metadata. And then in the second session, we'll talk about the web services, which are services that computers or machines can use to get data, make graphs and information. So I was kind of thrilled in Module 3 when you doers gave me a perfect follow-up for this activity. So someone asked, we would like chlorophyll data in the Southwest Atlantic. And because I also work with the Ocean Observatories Initiative, I knew that they have an array, or they had an array, it was discontinued, but they had an array in the Southwest Atlantic. It was called the Argentine Basin Array. And we're going to go into, so I'm going to try this now in the recording. I'm going to try going into the ERDAP server. I'm going to copy. Oh, I can't copy from the slide. I need to remember to search for chlorophyll Argentine. And I need to remember to just click on the apex surface mooring. Here we go. So again, you don't have to find this. We're going to go directly to the ERDAP server. Chlorophyll Argentine. Unfortunately, it's an HTTP, not HTTPS. So I had to get past that. I wanted to go to the near surface, I think it was, near surface instrument frame. Go into the data. Hope this is it. So in the live session, we will interact with the manual form. This is the data access form. And I want to look at the whole time period. So I actually don't want any time constraint. And I really only want to look at chlorophyll. So I'm going to uncheck all these other things. So I just have time, just have chlorophyll. Right now it's set, the file type is set to an HTML table. If I submit this, I should see a table. It starts back in 2015. Here is, you might actually remember this. This is a CF standard name for chlorophyll mass concentration in seawater. The units micrograms per liter, and this looks reasonable. Step backwards, back to my data form. In the live form, let's make a graph. I'll have to interact with this and again change. I don't want any constraint on the time. X-axis, I want time. Y-axis, I want the chlorophyll. Color, I just want whatever color. Redraw the graph. This should show me, oh great. So I'm seeing a graph. It looks like there's a few years of data. The values look appropriate. I'm actually seeing possibly seasonal cycles. This is looking like useful data. And I can go into the metadata and learn more. This has a lot of the definitions, the provider, just a lot of the metadata. Actually, you can see how long it is. A lot of the metadata is available. Let's go back to the data. And the cool thing about ERDAP was the formats. So, wow, how many formats. We'll end today's lesson just by finding a format. I see comma separated variables. NetCDF is one of the other formats we highlighted in module 3. I'm going to end this with a CSVP because I know I'm going to use this in my R script later. So I've selected a CSV. Designation P means a CSV file with one line header, including the units. I'm going to generate the URL, and then we'll talk about that later. Great. So again, I was just showing you an example of manual interaction with the ERDAP web application. And in the breakout rooms, we have amazing seafarers lined up to lead these breakout rooms. We'll have a breakout room for the US iDOOS program, and this will be for those already familiar with ERDAP. So they'll cover some more advanced features. We'll have a breakout room to continue on this Ocean Observatories Initiative example and Ocean Networks Canada. We'll have a room for the CC, HDO, and Ghost Ship example, which will be people interested in CTD and bottle data. And we'll have a room for some of the European data servers from the EMODNet and EMSO. And then we'll follow up, see how people did. What did we learn? What do we see? As we come out of that reuse by doing, I want to remind people about that we just reused some data, right? And so this anchor article for the day is not just, it's basically, you also want to give credit for using that data. And rule 7 of the paper is get that data citation. So it's not always easy to cite data. It's not as easy as citing a paper sometimes, right? So this set of bullets is commonly used today. It was proposed a couple years ago by the Earth Science Information Partners and has been adopted within our domain, for example, by the AGU journals. So the idea is to create a data citation similar to citing a paper, but being kind of more explicit about the contents of the data and the version and things like that, so that think about directing someone who's going to reuse your data, directing that end user to the subset that you used. Question to the room: have you ever cited data formally in a references section? Sometimes journals may ask you to it's kind of citing your own. So when you have a data product with your paper, there's often a data availability statement in the paper. This is not the same concept. This is when you are reusing someone else's data and adding that reuse citation into the references section. And I'm grabbing here this is from that DOI I had on the previous slide. This is an actual snapshot from a paper. It's in an AGU journal. Here's the paper. And I just did a screen grab. This is the data citation for data reused in that paper. And I'm just going to show you how it fits the bullets from the citation slide. So we have a creator. Now in this case, the creator is the repository, so they don't have to fill in the repository. You can actually find this repository in RE3 data, by the way. They have a release date, which was from the DOI landing page, and a title from that landing page. So because this is from a DOI with a date, it was not versioned, there's no need to add the access date. It is as it is from the landing page. That is not the case for what we just did in ERDAP, right? ERDAP is a live data server. So golly, this is harder to cite, right? So here I can't tell you this is perfect. I can't tell you this is exactly what a publisher would want. This is my guess at how best to fit those bullet items. And I'm also using the OOI how to use cite and acknowledge data webpage. So I am just filling in these bullets as best I can. I've provided the creator. In this case, the creator, it differs from the repository because OOI has a number of repositories. So here we are declaring the exact repository. We use the Data Explorer ERDAP. I pulled the title, but then the title wasn't enough to tell someone what I used, right? I used the chlorophyll data for this whole time period that was available to me. Where did I find the date? I had to go into the RSS feed for this ERDAP server. I can do that in the optional session to show you how to find this, but the data, because it's a live server, they have been refreshed. They weren't from 2018. In this case, the resolvable ID, I gave the landing page for that data set as a whole, which is another reason why I had to add something to the title, and the access date when I made the slide. So in homework, we'll ask you, you have a whole week to do this. Please do this. I want to use the homework answers in session 2. I'd like you to reuse and create a citation for some data that you're interested in. I'll create the form in time. Don't worry. It's just I don't have the form yet, but I'll have it on Thursday. And then, of course, after each session, I ask for some immediate feedback. We'll try to respond, and you know, I love to get back to any questions in time for the second session. So we'll keep the Zoom open for some feedback and peer-to-peer mentoring, and maybe to show some more steps from that ERDAP example totally up to you if you want to stay. All right, let's get into the second session of the module 4, reusable data. I'm not going to spend time on these introductory slides because we are just in the recording. You can scroll back to the beginning of this recording to see how we're going to use Zoom. You've just seen the first session with the preserve step. We will get into the reuse step in the breakout rooms and homework. So what are we going to learn next? This is it, the second session of module 4. We are going to talk about reusable data. I'm going to highlight what I think is most important with regard to the R and FAIR data. We're going to discuss these important points and tools to reuse data. Again, it's when we meet together that we find out about the tools that others are using. We'll end with the second anchoring article for this lesson by Tina Peer et al. And great. So I'm hoping that people will do the homework. So we'll be able to see some of the data citations. We'll be able to talk about it perhaps in the breakout rooms just to see how easy was it to create a citation and how easy was it to reuse the data that you're interested in. That's going to lead us into reusable data. And out of all we could talk about for reusable data, I'm going to only highlight 3 things. I think these are the 3 most important things. Others might think differently, but this is what we're doing for our deep ocean early career researchers. I think people need to have some familiarity with application programming interfaces or APIs. We need to talk about metadata again, and we need to talk about licenses. APIs. All right, first of all, I personally have heard this acronym for, over a decade. And I'm gonna give you these, this kind of a definition here and everything with a caveat. An API being an application programming interface for machine-to-machine communications. This is how a computer can use a service, can use data, for example, data over the web are web services. So web services use APIs over the web. So I can't give you a perfect definition. And I actually, even though I use APIs and web services, I don't create them. So I'm not an expert, but I know why I care. I care about APIs because I can use them. I can use them to pull data directly into my software environment. I can use them to subset data so I don't have to download everything. I can use them to have more efficient workflows. And so although I can't give you the perfect definition today, or in the live session for that matter, I'm going to show you why I care about APIs. And what's most important, I think, in this learning by doing is to understand that I'm going to use web services I'm just going to show you the pattern in a URL. It's going to help you see literally how you could even write into a computer program your own pattern to subset data out of an ERDAP server. So this very simple URL example, which gives you a domain, a directory, and a file to go to, this very simple example really is what we're gonna see out of the ERDAP server when we generate the URL. What did we see in that first session? The first session, if we scroll back here in the recording, I initially created an HTML table, right? And then I clicked submit, and then we saw a table. We saw a web page. We saw HTML text, which had our 2 parameters selected, time and chlorophyll. The last thing I did was I selected CSV, a CSVP in particular for a top header line, and I generated a URL. If that page is still open, yes, it's still open. I generated this URL. I can copy that URL. I copied it and I pasted it right here. If I were to click on that, it's kind of annoying because it's not going to show you a web page. It's a CSVP. But I'm going to show you how awesome that URL is. Before I click to the next slide, I'm going to go directly into my R. First, I have to click to the next slide to remember. Okay, here again is that URL, and it shows you the generic URL pattern with the namespace being the data server, in this case, the Data Explorer ERDAP server. ERDAP and table DAP, this could show grid DAP if you're doing gridded data. So here's ERDAP and table DAP. The dataset ID is this is the reference designator for that global Argentine fluorometer. The file type CSVP, and then I queried on time and chlorophyll. Okay, so I just have to remember in my R, I just need to read.csv the URL. Here we go. I'm not even going to have to open any packages because this is in the base R. Oops, I got to type in here. Read.csv. You're going to believe it when you see it. I'm going to just paste in that URL. And here we go. Well, let me make sure I'm at the end of the line. Tell me you work. It worked. Going into the data, what do I see? I actually see interesting. I actually grabbed more variables. If I look at the URL, I don't have that very simple URL from the slide. Here I'm seeing time, chlorophyll. I also see salinity. So as I look here, I have the time column, I have the chlorophyll column, but I do have a few more columns. Salinity here. The values look good. If you follow directly the URL from the slide, though, you'll just see the simple table like we saw for the when we generated the HTML table. You don't just have to use R. Guess what? This works in Python very similarly. In this case, I recommend the pandas package to be able to read the CSV file directly from the URL. How efficient is that? I didn't have to download anything. And how efficient is this? Thank you to Keith and our seafarer, Don, for providing this example of how the Esri tool, ArcGIS, can use ERDAP Web Services to pull data directly into ArcGIS. And Keith, a quote from Keith, this is less than 5 clicks in this case. An example, why not? I think I can open this link to show you the ERDAP server. Here's the ERDAP server for this NOAA ship. There's a lot of variables selected when you open it, but I'm sure that Keith is parsing out just the ones that they want to plot this particular, looks like he's plotting speed of the ship there. And can you see the pattern? So I actually went into the landing page for this layer, and the pattern is, so again, here's the data server, ERDAP table DAP we saw before. Again, you could have grid DAP if you're looking for gridded data. The data set file name, and then in this case, the type is GeoJSON. That's where we had the CSVP before. So with regard to formats, we highlighted NetCDF and CSV in Module 3. We just mentioned GeoJSON. So I'll refer back to the homework. Did anyone need to transform between formats to reuse data? All right, so let's see if we get any answers on that in the room. And then I'll head into the metadata. Why? Because way back in Module 1, when we defined fair data principles in our anchoring article by Wilkinson et al., we saw that the R principle talked about metadata, meeting community standards, and providing provenance for the creation of data products. So in order to reuse the data, what do we need? This is a great screen grab figure from an Anchor article from today. So we'll talk about the 10 appear at all article shortly. This graph shows you in green is agreement. So number one agreement here. I would have increased confidence in reusing data if the data were accompanied by written details about the collection and quality assurance. By the way, so this is part of data provenance. They did also have an explicit question requesting detailed information about the provenance, by the way, spelled wrong there, detailed information about the provenance available with the data. But these two columns to me represent provenance about the collection and processing, the creation of that data product. This column here is that the data users want to know more about the metadata standards that were used. So for example, for many of the ERDAP servers that we just interacted with would be following the climate and forecast conventions for metadata. Last point, licenses. We haven't talked about licenses yet. In Module 1, in the Wilkinson et al. Paper, the very first R is with regard to licenses, but I like this question from the paper even better. Does the researcher have permission to use the data from these third-party researchers, and under what license conditions? Oftentimes when we're submitting data to a repository, you get to the very last step and it says, pick your license. Oh my gosh, what license is best? There's this wonderful resource online, choosealicense.com, and their non-software page is very useful for data licenses. The software page is also useful for software licenses. These are different sets of licenses, by the way. The data licenses are very similar to what you would pick for your journal article itself. And I found this Fair Cookbook, a European, web page with some other training materials. I found it helpful in describing data licenses. So these two resources are very useful, help you choose a license. In Module 1, the Good Enough Practices article by Wilson et al. Recommended Creative Commons licenses, and as well the Wood-Charlson et al. Paper that we just read for today recommends these no rights reserved CC0 license or CC by attribution license for data. And again, licenses are different for software. So an open source license such as MIT, BSD, or Apache. All right, so at this point in the live session, we are going to move into the breakout session, or breakout room, sorry. And this is a real follow-up because way back in Module 2, we started a Jamboard, which was to talk about different tools that we use for every step in the data lifecycle. And we're going to go back. We're not actually going to open the Jamboard, but I am going to, before the live session, I will populate the reuse and the preserve Jamboard with a couple of the tools that I actually talked about during this recording. I'll give a couple different color. We'll have a couple more sticky notes here, but this will ultimately, I'll listen in and find out what you guys talk about during the breakout rooms, and we'll add some more tools here so that we can use this Jamboard going forward in terms of the tools that are useful to us as the DOERs community with regard to submitting or reusing data. So before we move into the breakout rooms, we can use the breakout room to discuss, how to reuse data, discuss, what did we find in our homework? What were the challenges in reusing the data? Or we can literally just talk about the tools that we want to use, because this is our time to be together. And as an example for tools, I pulled this quote from a Slack working group that I'm involved with. I want to thank Seafarer Matt Biddle from US iDOOS for this question. And the question is, anyone use the R package tidyNC? So why did I pick this one? Way back in Module 2, we had a doer ask about transforming data in between NetCDF and Tabular. And when I saw tidyNC, I thought, wow, I don't know this package. And when I think of tidyR, I really think of tabular data. So I'm curious, right? Yeah, I want to know, should I use this package? And this is your opportunity to ask others what tools are working for you. How do you find out about that latest R package? We'll have seafarers available to lead the breakout rooms. We might structure the room by discipline, or we might structure the room based on just what comes out of the homework in terms of challenges or solutions that people found. Now we're at the end of Module 4, and I want to highlight this concept of the preserve step leading into the reuse step. Let's just call it all sharing, the share step. And as a UN Ocean Decade program, I'm acknowledging here the data and information strategy for the UN Ocean Decade. And here is a direct quote. We, as scientists, ocean knowledge professionals, we still experience considerable difficulties in submitting, finding, accessing, and using existing ocean data. So I just want to acknowledge, it's not easy to do the preserve step. It's not easy to do the reuse step. Let's work together and make it easier on ourselves and others, right? And there's a brand new Ocean Decade Coordinating Office for ocean data sharing. It's brand new this year. I'm pretty excited for it. We got a decade to go with this, right? We got till 2030. Why share the data? So I even need to know this, right? I need to have benefits. So that paper by Wood Charlson et al., getting and giving credit. Why share your data? It's a benefit not only to ourselves to gain credit for our work, boosting our collaborations, increasing exposure to our work. It's a benefit to science as a community resource, enabling new discoveries. It's not just for transparency of our own research, and transparency to boost public confidence in scientific research. It's a contribution to scientific advances, to management and policy, etc. So it's important to realize this because it does take effort, right, to share your data this way. So to end Module 4, we're going to look at a survey that was done 5 years ago. We're going to see how do our opinions today compare to these from 5 years ago. And this was a survey of all the members of the American Geophysical Union 6 years ago. The respondents were from both earth sciences and life sciences, so we represent that as well. And about half the respondents were from the US. So again, I believe I actually have to look, but I think this percentage-wise is pretty representative of the doers. So in the room, we will have the doers respond to these 2 questions. For others to use my data, I would expect the following in exchange. First, we'll ask citation. Then we'll ask about data provider as in our opportunity to review the results. And we're going to compare our live results to these results in the Tenopir et al. Article from 5 years ago, in which most respondents expect citation, but only a third of the respondents actually require review of the results or would like the review of the results. Next, we're going to ask the room these 2 questions: agree or disagree Lack of access to data generated by other researchers is a major impediment to scientific progress. Data may be used in other ways than intended. Going to the article, starting with the lack of access as an impediment, yes, 3/4 of the respondents agreed. And 3/4 of the respondents also agreed that data may be used in ways other than intended. And I want to end with an awesome example of scientific progress that was enabled by reusing data. I just came across this paper. It's a brand new paper. It's related to DOERs research, but I don't actually, I looked at the author list. I don't think that any of the authors are doers, but please correct me. I know some of the authors, but I don't know all. So this is literally just a current paper that I'm just highlighting because I think they did a awesome reuse of data, and they answered a scientific question by reusing data. I'm highlighting here several data resources that were used in this paper, some of which are DOERs partners in the diagram that I showed earlier slide. I highlight those here. The International Seabed Authority's Deep Data Database and the Ocean Biodiversity Information System. I'm also indicating those data resources that are in the RE3 data that we looked at earlier in session 1. And as always, we'll end the session just by asking, what did we learn? Do we feel that we can apply the reuse step to data that we care about? Can we understand the concept of reusable now, the R in FAIR data? Do we remember concepts related to the preserve step? DOI, persistent identifier, including ourselves and ORCID? And I'm actually going to end with rule number 1 from the Wood-Charlson et al. Data paper. Appreciate the FAIR data principles for what they are and are not. They are not everything, right? So in module 2, we have a slide. FAIR is not the same as open. Open is not the same as FAIR. FAIR data principles are, however, very helpful in being able to for people to find, access, and use the data that are shareable. What have we learned in this course? We have learned the FAIR data principles throughout the 4 modules. We have learned and laughed, hopefully, along the way. We've learned the research data lifecycle. What can we do going forward? I love these 10 simple rules papers, right? So here's a 10 simple rules for implementing open and reproducible research practices after attending a training course. Here's your resource. Strategies to learn more include other online resources for self-paced learning, joining and creating communities. Right now we have our DOERs Slack for the DOERs community. And the Ocean Teacher Global Academy offers quite a number of other online learning that you can do. And you can look for these workshops in 2024. I've highlighted some materials from these workshops in previous modules from previous years. I'll ask for some feedback. The feedback I'll again incorporate into the slides when I package them into the final content. I want to thank the National Science Foundation again for the iDOOS project. And this training program was based on a workshop series developed at my institution a couple years ago. And we'll publish out these materials soon with a Creative Commons by license. Thanks. So this will conclude the live session. And it concludes our FAIR data training.